So in this video I'll going to impart you training on group theory. So in this video I will be giving you notes for group theory as well as some question answers which often come in university examination for group theory. So what is binary operation? What is binary operation? A binary operation is an operation on two elements of a set to produce another element in the same set. In other words, a binary operation is closed over the set of elements used by the operation. Like if you have a set of real numbers, if you have the operation as addition, then if you add any two real numbers, the result you get, that will be also a real number, right? So the resultant, the result all will belong to the set of real numbers. The result will belong to the set of real numbers. So that is called binary operation. So binary operation is the operation in which two elements of a set combined to produce another element, and that element, the produced element, the resultant, the result will also belong to the set, right? For an example, I have told you that the set of real numbers, if you take any two or three of real numbers and add all of those, whatever result you will get, that will be real number. So this is the definition for binary operation. Before understanding group, you have to understand what is binary operation and what is called the binary structure. Okay, so you have to understand what is binary operation and what is binary structure. So first you will learn what is binary operation. So what are the binary operation? Common binary operations are binary addition, binary subtraction, binary multiplication and binary division. Okay, these are the common binary operations. So what is binary operation? I think you have understood. And what are the common binary operation? And those are addition, subtraction, multiplication and division. Now what I told you, I am just giving you an example, that now consider set of real numbers R. Okay, then if we add two real numbers, then we will get another real number, and all of the three numbers will belong to the set of real numbers. So here we can say that set of real numbers, okay, are closed under the binary operation addition. Okay, so set of real numbers are closed under the binary operation addition. Now so that I have written here. Okay, so if you do the subtraction and multiplication, the same result you will get, but for division you will not get the same result, because if you going to divide any real number by 0, then the result will be undefined. Okay, so as the result is undefined, so that should not belong to the set of real numbers. So division is not a binary operation in case of real set of real numbers. Okay, now what is binary structure? What is binary structure? A binary structure is the combination of binary operation and a set. Okay, how we write the binary structure? Within the parenthesis, first we write the set and then we write the binary operation. Okay, like for real numbers we can like that R, and often the binary operation is denoted by asterisk. Okay, this is called asterisk. So R, so within parenthesis you can see R and then asterisk. So what will be the asterisk? Asterisk can be addition, can be subtraction, can be multiplication, but cannot be division, because set or real numbers are not closed under the binary operation division. Okay, so this is called binary operation and this is called binary structure. So before understanding group, you have to know what is binary structure and what is binary operation. Okay, what is binary? First you have to understand what is binary operation, then you have to understand what is binary structure. Okay, next, What is group? Let G be a non-empty set and asterisk be a binary operation on G. Then the set G together with the binary operation called group if and only if the following axioms are satisfied. So what are the axioms? The first axiom is if A, let us suppose you have a set let A which has 2 or 3 elements called 3 elements A, B, C. Okay, so if AB belongs to you, because you have the set G, okay, which has the member ABC, so it is obvious that AB will belongs to AB will belong to G. Okay, then if you do any binary operation among A and B, that will also belong to G. Okay, this is the first condition, and this is called closure. Now, if we have ABC that I have given you, I have already told you that let us suppose a set G which has member ABC. So if ABC belongs to G, then A binary operation B binary operation C will always be equal to A binary operation B binary operation C. Okay, this is called associative law. Okay, and then there exists and next is existence of identity. So what is identity? There exists an element E of set G such that A binary operation E equal to E binary operation A equal to A. Okay, for all elements A belongs to G. Okay, now and next and this is called existence of identity. Now next is inverse. Okay, so what is inverse? For each element A belongs to G, there exists an element A inverse such that A binary operation A inverse equals to the identity. Okay, so the element A inverse always called A inverse. I mean, the inverse is always represented at A. If A is the element, then its inverse will be A to the power minus 1. What I have written here. So let us consider a set, okay, G, which have members 0, 1 and minus 1. And let us consider in binary operation addition. Okay, so let's check whether this set G with members 0, 1 and minus 1 with addition as binary operation forms a group or not. Okay, so first what we have to check? First we have to check the closure property. So let us suppose 0 is, I have given you the example, let 0 be A and 1 be B, and if we add 0 and 1, what we will get? 1. Okay, and the set is 0, the member of the sets are 0, 1 and minus 1. So the result of addition of 0 and 1 belong to set G. Next we add 0 and minus 1. Okay, what we will get? Minus 1. So minus 1 also belongs to set G, right? Now if we add 1 and minus 1, okay, so what we will get? 0. So 0 also belongs to set G, right? So we can say that whatever, so if we consider addition as binary operation, and if we add elements 0 plus 1 and then 0 plus minus 1 then and plus 1 plus minus 1, whatever result we get, that also belong to G, correct? So closure is satisfied. Now we have to check the associativity law. Okay, so how can we check? We can check like this: 0 plus 1 and then plus minus 1. What we will get? 0. Again 0 plus 1 plus 1 plus minus 1. What we will get? 0. So what does that mean? That means it is associative, right? The addition is associative for these sets. Okay, again so 0 plus 1 plus minus 1 equal to 0 plus 1 0 plus 1 1 plus minus 1, correct? So we can say that this is associative, because however as per the associativity law, A binary operation B binary operation C should be A binary operation B binary operation C. Okay, and that is happening for this set. So you can say this is associative. The set members the binary of addition of binary operation under G is associative. Okay. Now next, what we will check? We check the identity. Okay. So what will be the identity here? Here identity will be 0, because if you add 1 with 0, what we will get? We will get 1. Okay. If we add 0 with -1, what we will get? -1. So what was the property of identity? If we do any binary operation with identity, we will get the same element, right? If A be the element and E be the identity, then if we do the operation, if we do the binary operation with A and E, we will get A, right? So here, if we consider 0 as E, and then binary operation addition, and then the element A as 1, then we will get 1. Again, if we consider 0 as identity, do the binary operation, and if we have the element -1 as B, then what we will get? B, right? -1. So you can say here the identity also exists. Okay. Now what we will have to check? Now you will have to check the inverse. So what will be the inverse here? Here 1, you can see that if we add 1 and -1, okay, if we add -1 and -1, what we will get? 0. Okay. What is the 0? 0 is the identity element. So we can say that -1 is the inverse of 1. Okay. So we can say the inverse also exists here. So we can say that all the four properties are satisfied here for the set G, we having members 0, 1 and -1 with binary operation addition. So this is how we can prove that this binary structure G with addition as binary operation is a group. Okay, so this is this. So what we learned today? We learned what is called binary operation, what is called binary structure, and what is called group. Okay, thank you for watching.